Coldharbour Marine.
Thank you very much.
My name's Andrew Marshall, I'm the CEO, and I'll be your guide today.
Thank you so much.
Nice to meet you, Boris.
Nice to see you.
You'll recognise this when you go out there because you're going to have a look at one of those. And that produces the inert gas. And then we squash it so that it's under pressure. And we send it down the deck lines to these things, which are mounted.
What inert gas is it? Argon, neon?
Well, it's mostly nitrogen.
Nitrogen.
It's about 13.5% CO2. And what you do is you blow the inert gas in here.
Yeah.
And this is just, as you've ballasted the tank, all of this is filled up with water. The whole lot, it's all just filled up with water. As we are introducing that gas into this plenum here to make the pump work, we do it via one of these things. Well, actually several of these things. And what these are gas-powered ultrasonic actuators. And what that means is every bit of water that comes up the pipe, don't Google it because it doesn't exist.
No. It does. A gas-powered ultrasonic actuator.
Yeah. So basically what I'm going to do in this area of the GLD, which is what we call this thing, gas lift diffuser, I'm going to create a standing shockwave of ultrasonic energy. Now you are old enough to remember when Ella Fitzgerald used to sing to a wine glass and shout, it's exactly the same principle.
Fantastic.
If you get the right frequency and amplitude,
fantastic.
you basically rupture the cells that pass
Unbelievable.
it.
Do you remember, did you ever read Tintin books by any chance?
A long time ago,
Do you
Boris.
remember the Calculus Affair?
Go on.
Do you ever read Tintin books? No. Okay. Well, they use the same thing to destroy cities. But anyway.
Okay,
Yeah.
so we have a little finesse
Yeah.
because we add a little bit of extra gas at the bottom,
Yeah.
and that gas we turn into little tiny champagne bubbles of gas called microbubbles. And so as the water's coming up the pike, it also picks up its supply of microbubbles. And what they do when they hit that shockwave is they microcavitate. Now, if you've ever seen what cavitation does to a bronze propeller, you can only begin to imagine what it does to organisms in the water. So that combination.
Tell me what happens when a champagne bubble of CO2 microcavitates.
Well, basically, how you have a spot release of energy that's massive. You have like a 2,000 degree spot release of temperature. You have several, I think, how many bar is it pressure drop across that? It's a lot, isn't it, Frank? 100,000 bar. There you go. Right. Ask a process engineer when you want to know stuff like that. Frank has just answered the process question.
So when the bubble bursts,
Yeah. So here,
when the bubble collapses, fantastic. Okay.
So it divides into two,
Yeah.
and it collapses. It gives rise to temperature, very high temperature and pressure, which disrupts the cell.
Yeah.
And that's where our technology is quite
And
critical.
you've been able to show that with cavitation, what's it called, microcavitation, you can collapse any type of bacteria.
Any type of bacteria.
It's fantastic. It's very, very beautifully made bit of kit, isn't it? I mean,
Yep.
unbelievable.
That will produce 4,000 cubic meters per hour of inert gas. That's enough to treat a VLCC on a typical journey. That whole thing. Come up and have a look. And the difference in technology involved in securing a stable combustion at very low oxygen levels with zero soot production, never been done. Then
I
typically,
want one. I want one. I want to generate some inert gas.
fine.